Good morning. I hope you're doing well. I'm doing well. I've had a somewhat productive week. It's been interesting. I think we should just get straight into it. My first slide is, I don't know, a good segue into what I was just about to say, which is that it is going to be probably, I expect, a fairly short stream today because last weekend and until Monday, so like Saturday, Sunday, Monday, I was participating and completed a very nuts bike ride that is easily the most difficult bike ride I've ever done. It was over 3 days, just under 300 kilometers and just under 6,000 meters of elevation gain. It was nuts. My knees are sore. My body is sore still. Yeah, so I lost Monday and then also like a bit more just in recovery time after that. And I've been not super motivated to do, I wasn't really in like the right headspace to do a lot of programming stuff, so I didn't do a huge amount of that this week. But I did do some. I did what I wanted to do last week. Who do you? Nice, good to see you here. Yeah, so not a huge amount this week, but some very, very useful things got done, which is very good. So some quick updates. The bearings are in and they are solid. So these bearings are the bearings in the thumbnail for this video. So I can actually show you on the CAD if Onshape would stop disconnecting. Let me bring this up. So these bearings in here were previously a little bit loose, and that meant that this bolt that comes through and attaches the legs onto the platform, that whole system was a little bit wobbly because those bearings were not held in place very well. I have now gone around and put those, locked those in using JB Weld, and this is the first time I've used JB Weld, and it seems it's pretty easy to use. It wasn't too tricky to apply to all the bearings, and we can see this, not that one, that one. Jugglebot is currently in something of a state of disarray right now. It's not in a happy place. So the platform I've got currently supported in my little car engine hoist, which is a little bit sketchy, but it seems to work. And yeah, so I used this because all of these legs are bolted on to the platform. But of course, as soon as I detach one of them, the other 5 are still screwed on, and vice versa. When I'm putting it back together again, if I connect one, the other 5 are not connected yet. And it just becomes extremely difficult to hold the whole thing. And this setup seems to work pretty well. I don't really have any complaints with it, to be honest. So let me zoom in a bit and I can show you what I've done. So this is a bad example. This is the only one that's a bit strange, which I will talk about in a sec. But yeah, basically, welded JB welded all of the bearings in. So they should, and I've clamped them down with a nut on the end here, and they should all be cured now. And I had a little bit of a scare yesterday, so I did this 2 days ago, and I'm just letting it cure for as long as I can, basically. And I'm kind of doing other stuff, so I'm in no rush to put it back together. But I had a little bit of a scare yesterday when I was just going around spinning all of them just to make sure that they all still spin freely. And one of them was binding up a bit. And I was a little bit panicked that I'd gotten some JB Weld into one of the bearings. But I think it was just between the nut and one of the washers, because after a little bit of persuasion, it gave way. And now they all spin freely. And I can't jiggle them around at all anymore. So they're much, much, much more solid than before. The only one that gave a bit of a hiccup was, funnily enough, the very last one, which is this one here. And I don't know if you can really see in the stream, but there's no nut on the end of this. And this is because I wasn't able to change this one because I can't even get the shoulder bolt out. I have tried so many things. I've tried using pliers to clamp it to pull it out. I've got a mallet and I was giving it some pretty solid whacks for a while trying to get it out. It's stuck. Thankfully, the wobble is the least bad on this one compared to all the other ones, so I'm not too worried about it, but it definitely does have a little bit more wobble than the ones that have now been glued in. But I don't know what I can do because it's stuck. I have literally no idea how to get that out. And I don't know what's causing it to stick. It spins freely. The shoulder bolt spins completely fine. I have no idea. Maybe some Loctite that was on there previously has gotten in between the shoulder bolt and the inner race of the bearing, so it's like welded the shoulder bolt to the bearing. I don't know. In any event, it's stuck in there now, so yep. Also, I guess while we're on this camera mode, I'll show you. I also, just before the stream started, I finished this like 10 minutes ago, I have put in all of the new carbon fiber nylon end pieces, which I'll show you in the CAD. I don't know if this is very visible from this camera right now, but I've just installed all of those and they seem pretty good. So that part is this part here. So all of those are now carbon fiber nylon. And actually, just so we're all on the same page about what's the reason why I replaced those, some of them, I think this one is the worst, cracked. The old PDJ ones, you can see that crack running out from the insert there, and this one's actually cracked on both sides. I don't know if that's going to be very easy to see, but yeah, so not good. And this one, the insert is actually like working its way out, so it definitely doesn't really want to be in there. And I will note here, just for posterity's sake, that John has cautioned me against using the carbon fiber nylon parts that I showed off in last week's stream, because I could really afford to, well, all else being equal, it would be great if I was able to increase the thickness. I'm just trying to find a really good example of this in the PDJ ones. This one will work. It would be great if I could increase the thickness of this part around where the insert sits, because you can see that bulge there. That is not there in the print. Like this, where is it? This bulge here. The print is completely flat. It's only once I insert the insert does it expand out a little bit. And yeah, John was cautioning me to perhaps add a little bit more thickness there so that bulge is less pronounced. And yeah, I agree. All else being equal, it would be good to do that. But there's a couple of reasons why I haven't. Many of them are just purely circumstantial. Like, this is just a really good time for me to do this right now, so that way when I put Jugglebot back together again, all of the changes are made and it's all done. It's all back together. I don't need to worry about it anymore. Versus if I change the part, I would have to make changes to the model, dehydrate my nylon carbon fiber filament again, print them all out again, insert all of the bearings again. Like, it's a whole, I've got to do a bunch more things as well. Also, increasing that thickness will impede the motion in some areas. There are some of the extremes of the range of motion do have like the bottom part of this piece interacting. Maybe I'll show you in the CAD. It's a little bit tricky to show it properly in the CAD because Onshape doesn't really like handling the platform in its entirety. But like, in the extreme of the motion, this bottom corner here does go inside this like wedge in here, this groove in there. So if I increase that thickness, then it might get in the way. Yeah. So I am aware of the fact that this is not the best structure that I've got right now, but it should work. And to be honest, I'm fairly sure that only one of these parts cracked badly in the PDJ. I think one of them cracked a little bit, but like very, very, very little. And I'm 99% sure that this part, there's one that cracked really bad that I showed before. I'm fairly certain that this one cracked only because of one erroneous movement where the platform just like tilted in some cooked way and put like an absurd amount of stress into this one part. All of the other ones have not had that happen because that erroneous movement only happened once, thankfully. And so I think it should be fine. I mean, there is something to be said for the fact that maybe more erroneous movements will happen in the future, but hopefully not. Yeah, we'll see. Cool. Okay, so yes, almost entirely without hiccups. And all things considered, I'm pretty happy with that, to be honest. Of course, I still haven't put it all back together again, but I don't anticipate there being any real problems with that, to be honest. I think that should be pretty clean. I'm just gonna wait because I just did the Loctite, for attaching these carbon fiber parts into the rest of the leg. I've only just done that then, so I want to wait a little while for that Loctite to cure, and then I'll put it all together. And then we should be all good again. And actually, something that I've finally used my slow motion camera, which I'll get because it's cool. I'm finally using this now for actual useful things, which is very good. I'm slowly, like, I've got a little bit of a setup here where I can like kind of use it a little bit more easily, just like ready to go. Yeah, sort of like getting in the swing of integrating this into my workflow, which will be very nice. I have very high expectations for this in the future. But what I've been using it for now, or what I did use it for, is to provide some way to estimate or like qualitatively compare the pre-hardware upgrades to post-hardware upgrades. Our hypothesis, I don't really have anywhere to put this now. I don't want to balance it on top of the balls, it's a bad idea. The hypothesis is that because these bearings were loose before, that was causing a lot of slop in the system, and that meant that when the platform moves around, there's a little bit of kind of wiggle room in terms of where it can actually be. So if it moves somewhere really quickly, there's a really long settling time before it actually finishes there. And so what I was doing is I basically moved it side to side really quickly and took footage of it settling, essentially. So now I can see, okay, with these speeds and this sort of movement, this is what we see for how much settling time is needed right now. And then what I'm intending on doing is once I've like put Jugglebot all back together again, I can run those same movements with the new setup and we can compare that settling time. And hopefully it's markedly less in the new case. So we'll see. It should be exciting. Okay. So another quick update is that last week I mentioned that I wanted to change the way that my software was working. I know I said that this week was a hardware week, but there's a minor software thing in here. I mentioned last week that I wanted to change the way that my code works so that when we enter the active state, so the robot is active and ready to start moving, it will raise the platform up into like roughly the middle position, and then it will put all of the actuators into closed loop control so that they're ready to start receiving commands. And then also when we leave the active state and we return to standby, or if there's an error or something, anytime we have to leave the active state, it will automatically slowly move all of the actuators down and then turn them all off so that the robot is in like a nice controlled finished state. And yes, I have got that working, but you're gonna have to take my word on it because of course Jugglebot is not in a state to show this off right now. Yeah, so when we enter, we raise the platform to the middle position, put all of the actuators in closed loop control, and then when we leave, we return it to the stow position or the lower position and put them all in idle. One thing that I'll just note here is that when I mentioned last week how I really like the idea of only having as many actuators being like ready to move as is necessary. For example, if we're controlling the robot with a space mouse and we're just getting it to kind of like move around, we don't need the hand to be active because the hand isn't doing anything. So the way that I've implemented that right now is that when we enter active, all of the actuators, including the hand, turn on and they're ready to start receiving commands. And then when we choose the actual type of control that we're using, so it's kind of like we're in active, and then once we're in active, then we decide what is actually sending the commands. So right now, of course, I only have the space mouse control, and actually I've got another one. I've got a shell control where I can send commands via the like terminal sessions. But yeah, once we decide what form of control we want to use, then the relevant actuators turn on and off, basically. Yeah, and that, I don't know, that seems fine to me. Seems like a good way to do it. I hope. Cool. Next thing is, that's all the software for this week. The actual updates, at least. The next thing is that the Deutsch cables have boots. And this word confuses me in this context. I don't know why this is called a boot, but last week I mentioned how my cables, particularly this one, I don't really like how exposed these wires are in here and how kind of like, I don't know, I can't find like an actual reason why I don't like this, but it feels wrong to have these cables exposed and like having them bending around and everything. I don't know, I don't like it. It's not as bad on the other side. I got the heat shrink a bit closer on the other side, but it's still not great. But it turns out Deutsch connectors, these connectors, have what are called boots, which are the little, like a sleeve essentially that goes over the end and covers that up. And my hope is that it will support the cables a little bit more so that when there's any bending going on, the boot will take some amount, hopefully the majority, of that bending and transfer less of it to the wires. So that way these wires will have less likelihood of breaking over repeated bends. So I just need to buy some boots. Yeah, and thank you to Joe for letting me know that this is what they're called. Why are they called boots? That's such a confusing name. Surely like a sleeve or like a cover. Anyway. Okay, cool. Next thing. You may remember I have motion capture on its way, allegedly. I've still got no updates, which is frustrating. But in anticipation of this motion capture coming, it's definitely very present in my mind, and I'm trying to get as ready as I can, just because it's so exciting. I covered one of the new Russian juggling balls in retroreflective tape, and it doesn't really sit the ball very well. And I was thinking, okay, maybe if I just like pound this into a hand for like 1,000 throws, maybe this tape will conform a bit better and be perfectly spherical. Maybe. And I mentioned how Kai, the German guy doing his PhD on juggling robots, has also used, like he's covered a ball in retroreflective tape. And I really thought everything that I looked up and every time that this was mentioned to me, I was getting the impression that there was only one type of 3M retroreflective tape. Every time I Googled 3M retroreflective tape, it was always just the same one was coming up. I'm like, okay, cool, this must be the only one. And so I bought, you can see behind me, one of every color. And I was like, great, cool, now I can have lots of colorful retroreflective balls and we can test all the different colors and everything. But it turns out Kai used a different type of tape. It's driving me mad. So if anyone knows of any fun uses for retroreflective tape, I would love to know. I have a lot of it and I don't anticipate using it for Jugglebot anymore. Super frustrating, but that's how it is. And Kai sent me a photo of what his ball looked like at the beginning, and this is what it was. And yeah, you can see that's clearly not the same stuff. And he found a link for it, and it turns out this is the stuff, and it is absurdly expensive. Like $11 for a meter, which, I don't know, feels nuts. But I'm thinking I might just get that because it might solve my problems. However, this whole process of wrapping the ball in tape took a very, very long time, and I am anticipating needing to cover a lot of these balls. I would be surprised if I, in my lifetime, cover less than like 40 balls in this tape. I suspect it will probably be a lot more than that. So I want to have a system, a way to make these balls retroreflective that requires minimal effort, but also maximizing the amount, like the amount of retroreflectivity and also how long the covering lasts for. So yeah, those are two big concerns or big objectives. And so I'm kind of considering trying different options as well. So the tape is good, but it takes a while. I know that it works, which is obviously a very strong positive, but it takes a while. So some other options that people have suggested is some kind of spray, like, I can't remember, I think it was Euroka. I keep forgetting who makes these suggestions. But whoever it was, thank you very much. I am very appreciative. Rust-Oleum 214944 is this a retroreflective spray. There's also this Albedo 100 reflective spray. However, my concern with sprays is that, specifically like the Albedo one, is actually marketed as a non-permanent spray, and it's supposed to be used for like children's clothing and that sort of like fabric-y sort of stuff. And I don't really expect it to last hundreds of thousands of catches into metal or plastic hands. I think that over time that would wear off. And honestly, even if it wears off and gets onto the hand, that could actually be like explicitly a problem because it will make that hand start to be read by the cameras, which would be a little bit confusing for them, I would expect. So another option is glass beads, but if anyone knows of any sprays that will stay on forever, then that's a big pro. Actually, one other thing that I should mention that I would love, like a S-tier cover, would be one that lets light come out at the same time. I would love if the balls could emit light, like have LEDs on the inside and give that light out, as well as being tracked by the cameras from the outside. This would mean that we can use motion capture cameras to run like a full system of like 15 Jugglebots juggling like 200 balls, and all of those balls could be emitting light. They could have like synchronized LED patterns between them, while also being tracked. I think that would be perfect. Obviously, this cannot emit light at the same time because this is covered by opaque tape. So someone who can do that would be awesome. So another option is to use glass beads. And this is actually what makes this retroreflective tape retroreflective, is like tiny, tiny, tiny little glass beads. However, these seem a little bit tricky to actually use because they need to be, from what I've read, they need to be embedded in whatever is holding them, whatever is supporting them, like that spray or glue or whatever you use. It needs to be embedded just the right depth within that to be most retroreflective. I don't know what happens if you fully encase them. I don't know if the retroreflectivity just like stops working or something, but apparently anywhere between 45 and 55% of the bead should be covered for like primo reflectivity. And that seems tricky, to be honest. That seems very, very tricky to do. So I don't know how easily that would work. And also these have the same problem of the glass beads. For one thing, going everywhere. Like I've got carpet and there's going to be glass everywhere. And then also secondly, if they wear off over time, it will have the same problem as the spray had. So I'm not sure. A third option that I really like, but I don't think it addresses the problem of taking a long time. I suspect this will take a lot more time than the tape, is making a crocheted ball that goes around, like a crocheted sleeve rather, that goes around the ball. And making that sleeve out of retroreflective string, like what's used for like tent guy wires, and yeah, having that go the whole way around. I think that's a super, super interesting idea, and I don't know, I'm very inclined to just try it just for one, just to see how it goes. Yeah, I think it's very, very out of the box thinking. I'm a big fan of that. So yeah, I'm tentatively planning to make one ball covered in that way. I really don't think it will be a very fast process, but it could be cool to see how well that works. Okay, next thing. It is looking increasingly likely that we are going to need to make our own motion planner. So last week I mentioned how Ruckig may be making a return, where Ruckig is this way of basically saying, I have some number of actuators, I want them all starting here, I want them all to finish here. They have all of these limits of like how fast they can move and that sort of thing. Get them there as fast as possible. And yeah, it does that extremely efficiently. It is designed to be like time optimal, and yeah, it seems like fairly easy to use as well. However, John reminded me that it doesn't support setting a target arrival time, which kind of destroys its utility for Jugglebot, because we need to be able to say, you must be here at exactly this time. If you're there too early, you're not going to catch the ball, and you're going to be like moving out of the way of the catch before the ball has arrived. And if you get there too late, obviously the ball's going to be gone. So we really want to be able to have a very precise control over when the whole system is arriving at that at the state that we decide. So yeah, it seems like we're going to have to do it ourselves, which is interesting because this is an area that I definitely have the least expertise, well, maybe not the least, but a fairly low amount of expertise. And yeah, I'm hoping to spend some time on this next week though, to have some really careful thinking about, okay, the platform is here, the legs are all in the state that they're in, like the lengths that they're in, with the velocities that they have, because I want this whole thing to be moving quite smoothly now. And then take from this current position and velocities, go to here. But it's tricky, like, it feels like in my mind we want to be controlling the platform so that it carries its momentum through. My intuition is that we don't want the platform to ever stop unless the platform stops. We want the platform to always be, or if it's like waiting for like a really high throw to come in or something like that. Like, it should always be constantly moving just a little bit. Because anytime we stop, you have to control that stop and you have to stop that momentum entirely. And then also when you start again, you have to introduce a lot more energy into the system to get it going again. And just from personal experience, it feels like when I juggle, my hands are constantly moving. It's never doing like janky sorts of movements. It's always nice and smooth and round. And that seems fine. For controlling the platform to do that, I don't think that would be too difficult. But going from the platform to the 6 legs and making sure that when the platform is carrying out this nice, smooth circular motion, that none of the individual legs exceed their position, velocity, or acceleration limits. I don't know how that would work, and that's what we need to figure out. So yeah, a little bit of mathin is needed, but hopefully we should get there eventually. Yep. Another thought that I've been having is that it will probably be very useful to make a hand testing rig. And what I mean by this is I think it will be very useful to have some way to essentially print off different styles of hands. So here are some old ones that I've got lying around. It'd be great if we can just say, I've got, in this case, 2 different designs. Which one of these is better? Which one can catch balls coming from all sorts of different directions at different speeds and everything like that? Which one can do that better? And which ball is best for which hand? Like, right now, the process of changing that around is fairly time consuming, and the Jugglebot is not really set up to be swapping the hands really often. So what I'm thinking is that it could be really helpful to make just a rig with basically like essentially the hand system that we've got right now, where the hand is on a rail, a slider that can slide up and down. And I'll go through the features on here, I've got them written out. So there'll be a slider attached to either an adjustable spring or a mass, or just having it locked to the rail so that so the hand is just fixed there. And my intention with doing this, and we could also attach it to a motor as well. My intention with doing this is that we can compare how necessary it is for a given hand and ball combination to have the hand attempt to actually catch the ball. Something that we have been trying to do, John and I, is to make the hand match the speed of the ball as the ball comes in on its way down during the catch. And that is it makes the timing of the catch needing to be extremely precise, because like from the hand being at the top to being at the bottom of the rail, if it is matching the speed, then that the moment of the catch has to be precise within like less than 0.1 of a second. It's extremely, there's not a lot of room in there to get that wrong. However, Kai has noted that he doesn't do any velocity matching at all, and his approach is just to have a really big hand, and using these Russian balls, they just plop in the hand, and you don't need to match the velocity because there's very little risk of them bouncing back out like that one just did. Granted, that's because I flexed a bit, but still. So yeah, my hope is that by testing with connecting the hand to like a spring or a weight, or just having it locked, or even attaching it to the motor, then we can test how necessary it is to do this velocity matching and how much velocity matching we need to do. So the hand must be very easy to swap, because that's the whole point of this, is to swap the hands out. Another cool idea that I think would be awesome is to actually provide, to have a bit more of a qualitative understanding of what's actually happening in these catch events. We can have the hands have a hole in the bottom of them, like this one's got, and have a laser gate that can be used to detect when the ball has settled. So what I mean by a laser gate is essentially a laser on one side and a photodiode on the other side, and when the ball is in there, the hole would probably have to be a bit bigger than this one is, maybe. But when the ball is in there, the ball will block the laser, and we can detect that, we can infer from that blockage that the ball has settled. We may have to do some amount of like, but maybe the ball settles and then it goes back out again. So there might have to be some amount of like, okay, once it has settled for more than a second or something, like half a second or whatever threshold we want, then the ball is settled, and then we know that that's when the catch happened. And so that we can get a bit more of a qualitative understanding of what happens here, we can use that laser gate to trigger the end of a recording on my slow motion camera. So we can have the camera set up there, bang on where the hand is, and then have the recording stop nicely as soon as the ball has landed. So we can a great thing about this camera is that it can just record infinitely until the storage is full. So I can just hit record, drop the ball in, and then it will automatically stop when the ball has actually been caught. And then when I'm going back through the footage, I don't need to scrub through like minutes of just like nothing happening. I can just skip right to the end and then go backwards. And then we should be able to get lots of clips of like just the ball being caught, and we can see exactly what's happening there, how much is moving around, what it's actually doing. It should be very, very nice. I think before I go into actually making a testing rig like this, I think I would want to be pretty confident that I knew how to repeatedly simulate balls coming from strange angles. So right now, what I've just described will allow us to basically drop a ball in from above and then see like what's happening when the ball lands in the hand directly from above, or even maybe positioned a little bit off to the side or whatever. But if we're comparing different hands and different balls, this whole process needs to be very, very repeatable. Otherwise, our results are not going to be as useful as they could be. So I could use, for example, I've got this little dropper rig thing that's actually designed for none of the balls that I have out right now, but maybe it will work with this one. So we can basically just like pinch these together and the ball will come out. And so we could position this side to side and forwards and back and whatever, but this approach will not allow us to throw the ball in from the side. And that's obviously a fairly useful thing to do because it's not always going to be the case that the ball is coming in perfectly parallel to the rail that the hand is on. So we want to make sure that the ball can still be caught even when it comes in at some weird angle. And I'm not really sure how to do that repeatably. I've been thinking of like a horizontal rail that we can then slide the ball on with somehow getting the velocity the same. Maybe like a horizontal slider that this sits on like a little carriage and just gets like shot off the end. Maybe, but that seems like a lot of effort. So I'm not sure. Or we could always do it very qualitatively and I can just throw the ball in, but of course I don't know how useful those results will be if it's not perfectly repeatable. So I'm not sure. If anyone's got any ideas, then I would love to know. But yeah, in general, I think that some setup to compare different hand designs, I think would be very, very, very helpful. There's a lot of unknowns with regard to the hand, like how big do we make it? Kai has noted that he has had instances where he's got his robot set up and it can do like maybe, I don't know, like 30 or 40 catches of like 2 in one hand. And then he changes the hand to have, so his one's basically like a big cone with a hole in the bottom. If he changes the hand to have like a 2-degree difference on the slope of that cone, it might go from 30 or 40 catches to 30 to 40 minutes, which is like orders of magnitude more like performance. And it seems like it's very difficult to judge in advance which structure will be better. And we've also got questions of like, okay, right now, if we have a conical hand, it's still possible that the ball can roll around in the hand before it settles down. And maybe, what if we have, rather than a circle, like a circular prism, a cone, rather than having a cone, we can have like a multifaceted cone where it's like maybe like a triangular prism. Maybe there's only 3 sides. And that way when the ball comes in, it can't roll around because as soon as it slides along one side fully, it will hit the other wall and that energy is going to be dissipated. And then the ball will hopefully plop right into the middle a little bit more quickly. But how many faces is the optimum amount? Who knows? Yeah, so there's lots of different things to test with the hand, and I have the feeling that having a proper rig to just churn through all of the different options will make that process a lot simpler. But I don't know how to repeatedly get the ball coming in from the side. Cool. All right. Next thing, why does my Bluetooth always stuff up during the stream? Ridiculous. Okay. Now, I don't like this. This, to ROS or not to ROS? This makes me uncomfortable. Someone has posted on Zulip just asking questions about why I am using ROS for this project. And this makes me uncomfortable because for anyone who's been following this project for a while, you will probably know that my prior robotics experience is 0 before this project. And I was very much just like fumbling my way around in the dark before I came upon ROS. And a lot of people were suggesting, hey, like you're building a robot and ROS is designed for robots and it's used in industry and in academia and it seems pretty robust. Well, in their experience, it is pretty robust. And a couple of people convinced me to give it a go. And as soon as I started using it and actually understood what's going on, I really, really like it. it provides, for me, it provides a really solid backbone that I can use to then like structure all of my code on top of. So it's basically making me think of what I understand to be like the proper way of structuring my code so that it all communicates nicely. All of the nodes have separate tasks that they're responsible for. And yeah, for me as a novice, it's providing a really nice framework that I can work inside. And yeah, I've been finding that extremely useful. However, it does have some pretty significant limitations, which is frustrating. One of these limitations, I've only got one example here right now, is speed. So this graph was made, this was like all of this data was taken on a Raspberry Pi 4 with 2 gigabytes of RAM. So Jugglebot's computer is significantly better than this. But even as it is, the ROS benchmark Python is like the closest to what I'm doing right now. And this can send messages at a rate of 552 Hertz. Compared to, for example, using async IO, we can, on the Raspberry Pi, we can send 27,000 messages per second. So whatever that is, and like 200 times better or something, like way more messages per second. And I don't really know what to do with this information. I don't like it because I mean, on the one hand, I feel like I have a much better understanding of how this code should be structured now, so I maybe don't need to lean as heavily on ROS to provide that structuring for me. But on the other hand, I'm so used to ROS. And I think it would have to be very worthwhile for me to be motivated enough to switch over to something else at this point. There is a very present thought in my mind that like I am still in fairly early days of like redoing the code base for Jugglebot. So if I were to change over to a non-ROS setup, now would probably be a pretty good time to do it. But I just don't like, I don't know, I think that the TLDR of how I'm feeling, I think, is that there are so many things going on in this project, and changing from ROS to something else is just another thing for me to worry about. But I also don't want to back myself into a corner where I'm only limited to like 200 times fewer messages being sent across than I could otherwise be getting. Like I know that I'm really going to be kicking myself if in like 6 months' time I'm hitting some limit of how many messages I can send over ROS and I have to change over to async IO. I don't know. I think for now, unless some new information presents itself to me or someone sends it to me, that is extremely convincing for changing away from ROS, I think that I'm going to stay with ROS for now and then just deal with the consequences later. If I need to change to something else later, I mean, ChatGPT is only getting better and better, so maybe in the future I'll just be able to say, hey, here's my ROS project, turn this into async IO, and it can just do the whole thing, maybe. Obviously it can't do that right now, but in 6 months or a year, who knows? Yeah, that's my thinking. May not be completely sensible, but that's how life is, I guess. Yep, cool. All right, so that's everything that I have to mention. Actually, there's one more thing that I'd be remiss if I didn't note. Back on the hand, is that on my lights that I've got, they have these hyper reflectors, and I cannot stop thinking about these in terms of the hand. And I really want to see how this sort of shape works. Every time I look at this, it just like sits right next to me here. Every time I'm looking at this, I'm thinking like, oh, what if this was the hand? So yeah, lots of shapes to try, no doubt. Anyway, get in there. Cool. That's it for this week. There will be a stream next week, and hopefully I'll have some good news. I'm very, very keen to put Jugglebot back together, and I don't know, I'm very anxious about doing the first couple tests of it moving side to side. I really, really hope it helps the settling problem. I don't think it will completely have helped the settling problem, because like the bearings being wobbly is not the only source of wobble in the hardware. It was definitely by far the biggest one, but I mean, there's a lot of stuff going on between the platform and the ground, and there's a lot of chances for things to shift just a little bit. But I'm cautiously optimistic that the settling time will be massively reduced. So yeah, big fingers crossed. Cool. Okay. Well, I hope you found that interesting. If you have any thoughts on anything that I've gone through, then please let me know. External opinions are extremely helpful. Helps me stay on track and not get too, I don't know, off with the fairies. Cool. As always, good luck with everything you're doing, and I will see you next week. Have a good one.